Hello, grade 10 students. This is the continuation of our lesson in Science and Technology, grade 10. Our topic, distribution of active volcanoes, earthquake epicenters, and major mountain belts. By the way, this is your teacher, Constantino M. Gutierrez, or you can simply call me Sir Cons. To begin with, our learning competency, describe and relate the distribution of active volcanoes, earthquake epicenters, and major mountain belts to plate tectonics theory. For our specific objectives, 1. Trace the approximate location of earthquake epicenters, active volcanoes, and mountain ranges around the world. 2. Describe the distribution of active volcanoes, earthquake epicenters, and mountain belts. 3. Relate the distribution of active volcanoes, earthquake epicenters, and mountain ranges to plate tectonics theory. And the last, determine the scientific basis for dividing the lithospheric plates. Before we go further, let us revisit the map of plate boundaries. And you are going to consider the following questions. A. What is the difference between this figure in a regular world map? B. What do you think is the basis of dividing the world in such manner? To help you answer these questions, you are going to watch and listen to a short video clip to give you insights about plate tectonics theory. So here we go. Watch the video now.
That they were once all connected. In the early 20th century, a scientist named Alfred Wegener called this supercontinent Pangaea. He thought different chunks of it broke off and slowly moved apart. Over millions of years,
We don't feel this often, but we can see the results of the movement almost everywhere. The Earth's crust is what moves. Our planet's outer shell. It is not one piece, but instead is made of individual puzzle pieces, plates. They were all part of a continent that broke up over 200 million years ago. Since then, it hasn't stopped moving. This is called tectonics. Plates move slowly, as fast as growing fingernails. Continental plates form the land the continents are on. Plates that are covered with water are called oceanic plates. They are thinner and the rock is heavier. When continental plates collide, the folds can pile up and create huge mountain ranges up to 8 kilometers high. An oceanic plate pushes itself under a continental one. It disappears into the Earth's hot mantle, creating an ocean trench up to 8 kilometers deep. On its way down into the mantle, the oceanic plate melts. But the liquid magma can return to the surface at another place. A volcano is born. When two oceanic plates move apart, the seam is called an ocean ridge. Magma from inside the Earth escapes here. This drives the plates further apart and makes them grow. Plates that glide past each other can get tangled up and stick. When they separate, the Earth shakes. Earthquakes show our planet is anything but a calm place.
From our activity, the title, let's mark the boundaries. For our objectives, number 1, describe the distribution of active volcanoes, earthquake epicenters, and major mountain belts. Number 2, determine the scientific basis for dividing the lithospheric plates. For our materials, we have Figure 5, map of the earthquake distribution. Figure 6, map of active volcanoes of the world. Figure 7, map of mountain ranges of the world. 2 pieces plastic sheet used for book cover, same size as a book page, and marking pens. I suggest also to my students that please provide the world map with you right now. Also, you can have ball pens or pencils with you and piece of paper to write on. Hey, what is this? Yes, you're right. This simulation means earthquake. And the first map that you are going to observe and study is the map of an earthquake epicenters around the world. This is figure 5, map of earthquake distribution. The red, green, and blue dots represent the earthquake epicenters. Kindly observe the pattern formed by the colored dots and try to identify their locations in the map. While looking at the map of earthquake epicenters on the right, you are going to answer the following questions. Question number 1. How are earthquakes distributed on the map? Question number 2. Where are they located? I will give you 20 seconds to answer the questions. For the answer in question number 1, the world's earthquakes are not randomly distributed over the Earth's surface. They tend to be concentrated in narrow zones. Question number 2. Some are located near the edges of the continents. Some are in mid-continents, while others are in oceans. But not all edges of continents, mid-continents, or oceans can be places where earthquake might occur. Question number 3. Where are places with no earthquakes? Question number 4. Why do you think it is important for us to identify areas which are prone to earthquakes? Now, check your work again. For question number 3, where are places with no earthquakes? Large part of Pacific Ocean, northernmost Asia, majority of Europe, eastern portion of North and South America, and Western Africa. Question number 4, why do you think it is important for us to identify areas which are prone to earthquakes? It is important to identify areas which are prone to earthquakes so that necessary precautions could be done if ever you're living in one of those places. Any clue? Sure you get it. Next is the map of active volcanoes of the world. This is the map of active volcanoes. The red areas represent the presence of volcanoes. Kindly study the map carefully. Question number 5. How are volcanoes distributed? And the answer is volcanoes are not randomly distributed. Majority of them are found along the edges of some continents. Question number 6. Where are they located? And the answer, majority are found along the edges of some continents, particularly in the western coast of North and South America, East and Southeast Asia. Based on the map, state a country that is unlikely to experience a volcanic eruption. For the countries without volcano, we have South Africa, Nigeria, Zimbabwe, Malawi, Djibouti, Somalia, Algeria, Morocco, Tunisia, Liberia, Denmark, Norway, Wales, Finland, Sweden, Ireland. Okay, there are two maps on this slide. The map above is the map of earthquake epicenters, and the map below is the map of active volcanoes. You are going to use these maps to answer question number 8. Compare the location of majority of earthquake epicenters with the location of volcanoes around the world. Our answer: earthquake epicenters and volcanoes are both situated at the same locations. To answer the next question, you need to compare the three maps. The first map is the map of earthquake epicenters. The second map is the map of active volcanoes. And the third map is the map of mountain ranges. You are to observe the pattern formed by the red lines or dots on each map, then relate it to the location of earthquake epicenters, active volcanoes, and mountain ranges. Question number 9. How will you relate the distribution of mountain ranges with the distribution of earthquake epicenters and active volcanoes? Answer: mountain ranges are found in places where volcanoes and or earthquake epicenters are also located. Question number 10. What do you think is the basis of scientists in dividing Earth's lithosphere into several plates? Answer: geologic activities such as seismicity or occurrence of earthquake, volcanism, and mountain formation are the basis of scientists in dividing Earth's lithosphere. How did you score so far? If you score 1 to 3, that's good, not bad anymore. If you score 4 to 6, very good. And if you score 7 to 10, excellent. Okay, let us summarize what we learned in today's lesson. 1. Earthquake epicenters, volcanoes, and mountain ranges are on the same location. 2. The three bases of scientists in dividing Earth's lithosphere into several plates are: 1. Geologic activities, 2. Volcanism, and 3. Mountain formation. How I wish that you learned something from our lesson today. Thank you for watching and listening from our short video lesson. See you next time. Once again, this is Constantino Montero Gutierrez, your teacher.